right, so continuing doing our full review for Algebra 1, we're now going to finish inequalities today because we need to move on to funner stuff for tomorrow. So, our objective for today, I can solve and graph one variable inequalities. Once again, I can solve and graph one variable inequalities. Tell your neighbor what concept we're still on. That is correct, one variable inequalities. So, when we started with one variable inequalities, I had you fill out a prayer model. We're not going to fill it today to save time and move on to practice. I know some of you already started. You can finish that later. But before you do, look up to the screen. It's one variable inequalities. Think about the definition. Don't say it out loud, just think about it. This definition of one variable inequalities. Without looking at your notes, share with your neighbor the definition, please. We got it? All right. So let's see if he said this. Two expressions not equal to each other with one variable. And if you got something like that. Yeah. Examples on examples. Hashtag. Like I said, you can throw that in later for yourself. What process have we been using? Simplify, isolate, plot, and check. We're going to continue using that, but for today, we're going to be looking at a couple other things. I just want to do a quick recap of what we've seen so far. So here we go. So we covered that inequalities come from the scale. If it's not balanced, it's an inequality. If it's balanced, it's an equation. Yes? All right. From there, we fill out our prayer model. We got our steps, simplify, isolate, plot, check. And I'm going to do a quick review for this. Look up to the screen, please. Write your utensils down. All right. To solve this inequality, I need to leave x by itself. So what do I do here, everyone? Subtract 1 from each side. So therefore, we're left here with -6 less than x. So far, so good? Let's graph that. I create my graph. Here's 0. What's my dividing point here? -6. Okay. So looking at the inequality symbol, does it have an equal sign? No, so it's an open point. There it is. And now I'm going to test 0 here to see if it's true. Is -6 less than 0? Yes, since it worked, I'm going to shade towards 0. Have we covered that? Yes? Let me do another one. Here we go. Look at this one. To solve for x, what do we do, everyone? Subtract 1 from each side. These cancel. We're left with x less than 1. Therefore, let's graph this. You don't need to copy this. I'm just doing a quick review. What is dividing point on this one? Dividing point is 1. There it is. All right. So it's an open point. There it is. I'm going to test 0 again here. Is 0 less than 1? Yes. So that means I'm going to shade towards 0, and it does work. So now that we got all that out of the way and we're like happy and we're good, right? Today, we're going to crank it up a notch. We're going to cover today something called not complex. It's a combination of inequalities that we call compound inequalities. Let's see if you remember. I have an animation for this so you can see how they both combine. So look up, please. Check this out. I'm going to combine these two to make 1. But I want you to see that it's actually 2 and 1. Here it goes. Notice that I just combined both of them into 1. And it created only one inequality right here. Do you guys see that? But who notices now that we have 2 inequality symbols in one statement? That's what we call a compound inequality. So anytime you see something like this, that's our compound inequality. I'm going to show you or revisit this because your noodle should have it in there somewhere, yeah? All right, copy this example, please. Example 1 on your paper. To solve, graph, check, and write the solution set of -5 less than x plus 1 less than 2. Copy that, and I'll go over that one. All right, here we go. Write your utensils down. Look up to the screen, please. Focus. Please, pretty please. I'm going to go over this one really quick. It's fairly simple, and I'm pretty sure you're going to recall it pretty quick. I'm going to give you another one for you to do by yourself. Here it goes. Here we have a compound inequality. So just to make sure that we see exactly what we see, here's one inequality symbol and here is the other. So I'm going to draw a line down. But now we have how many parts? 1, 2, 3 parts. But we're still trying to solve for what? For the variable. So to leave the x by itself here, what do? Minus 1, minus 1, minus 1. We do that to all parts. This cancels here. What do we have on this side? You're just paying attention. Negative 6 less than x less than 1. Is everybody there so far? Since x is already by itself, now I'm going to graph. So pay attention. Here we go. To graph, I start with my 0. I'm going to start with the first part. Please focus. Stop copying. You'll copy at the end. Oh my goodness. Here it goes. I'm going to do the first part. My dividing point is what? Negative 6. It's an open point. To know which direction to shade, I'm going to test it with what? 0. So instead of x, I'm going to write 0. Let's see. Is negative 6 less than 0? Yes, that's true. That means I'm going to shade towards the 0. There it is. All right. Now I'm going to graph the second part. What's my dividing point? 1. It's an open point. There it is. And I'm going to test again another there. And I'm going to use also 0. Is 0 less than 1? Yes, that's true. That means I'm going to shade towards 0. So what do you notice now? That both graphs intersect. Everybody with me? When both graphs intersect, that's what we call an and compound inequality. Why and? Because any number in here is a solution for this side and for this side. Does that make sense? Now check this out. To write my solution set, I'm going to write it right underneath. This is probably the easiest one to write. What was the variable that we used? X. That represents the entire shaded region here that overlaps. I write my dividing point here, my dividing point here, arrows, and solution set of x. Copy that, please. Hopefully it's starting to ring some bells, yes? Yeah, copy that, and then I'll send you another problem once. So once you're done with that one, you don't have to upload that one, but you have to upload the one I sent you to the screen. Example 2 is 8 less than 3x minus 1 less than or equal to 11. Copy that and go. Yeah, so let me go over this one really quick. Here it goes. Focus, please. All right. So line down, line down. To leave x by itself, we have multiplication and subtraction. So I add 1, add 1, add 1. This becomes 9 less than 3x less than or equal to 12. What's my last step? Divide by 3, divide by 3, divide by 3. This is 3 less than x, because this is a giant 1, less than or equal to 4. Let's graph this. We got 0. I'm going to start with this part. What is my dividing point? You all right, Josh, over there? Okay. So it's an open point, and I'm going to test 0. So, is 3 less than 0? No, so instead of going towards 0, I'm going to go to the opposite side. Now I'm going to graph this part. Positive 4, it's a closed point, there it is. And I'm going to test 0 also. Ramon, focus. Is 0 less than 4? Yes, so I'm going to shade towards 0. And what do you guys notice? This is an and. And to write our solution set, we know that we're using the variable x. It goes there. Dividing point, dividing point. This is an open point. This is a closed point, so I do the equal sign. And lastly, solution set of x such that. Yes? Say that again? What? Yeah, so the question is, guys, they're asking, Mr. Q, so if we substitute the value of 3 in there, it's going to be false. Yeah, that's what the open point means, that it does not include that number, but starting from that and on. To test? Yeah, you can use any number. Yeah. All right, let's move on. Copy this one, please. The instructions you don't have to copy since you already have them, but it says 8 plus t greater than or equal to 7, or 8 plus t less than 2. Copy that really quick and I'll go over it. All right. So if you notice, it looks kind of weird, doesn't it? Yeah, because it doesn't look like the other one that we just did. Now it has an actual word in between two inequalities. However, it's still two inequalities, which is still a compound inequality. Therefore, what do we do, Mr. Q? Well, let's start one at a time. Line down the inequality symbol. Let's do this one together. What do I do here to solve for t? Subtract 8, subtract 8, and we're left with t greater than or equal to -1. Bring down the or. Now we're going to focus on this inequality. What do I do to solve for t right here? Subtract 8, subtract 8. We end up with t less than -6. Can I solve any more on each of the inequalities? No, they're already solved. At this point, let's graph. Here's my 0. Is that crooked? Yeah, right. There it is. Here's 0. I'm going to start with red for this side. What is my dividing point? -1. Is it an open or closed point? Closed because it has the equal sign, so I need to make a solid point. And which number would you like to test it with? 0? Or do you want to test it with -2? Okay, I'm going to test it with 0. So 0 greater than or equal to -1. Is 0 greater than or equal to -1? Yes, so I go towards 0. Here it is. All right. Next, I'm going to graph the second one. My dividing point is -6. -6. It's an open point. What number do you want me to test for this one? 0. Is 0 less than -6? No, this one is actually false. So that means I'm not going to shade towards 0. Where am I going to shade? The opposite direction. So what do you guys notice? They're not overlapping. That's why this one, the solutions for this inequality, it's either this or that, not both at the same time. That's why these are known as or. All right? Therefore, see what I did there? Solution set of t such that, and all I do is write my last statement that I ended up here with, which is t greater than or equal to -1 or t less than -6, and I'm done. What's that? Yeah, there's another symbol, but for right now, let's keep it like that. I don't want to get more into your noodle. I just want to make sure the process is there before we get into the symbol part. All right, I'm going to send you a problem so you can do by yourself. See how you do. There it is. Lock your toolbar. As soon as you have that, take a picture, send it in. Copy that and go. Just copy it. I'm going to show you exactly how to write our inequality, our compound inequality from there. It's very easy. I'm just going to walk you step by step just to recall, make sure we got it. It says, write a compound inequality shown by the graph. First of all, if you were to tell someone and show them this graph, what kind of compound inequality would you tell them it is? An and, that is correct. And, that is correct. If it's an and, that means that the solutions are here. Yes? So that means I need a variable. What variable do you want to use? X. So I'm going to write that right in the area where they overlap. There it is. What are my dividing points? -2 and 5. Okay. This is an open point, so it goes like that. This is another open point, so we don't put the equal sign on either. And there's our compound inequality. Hold on, yes? Okay, the symbol, whenever we are in and, it's always to the left. And hopefully this is ringing a bell, guys, because this is where we're going. Does this look familiar when we got to functions and relations, when we're looking at domain and range? Yes, that's why it's always pointing to the left, okay? However, am I done? No. Solution set of x such that, that. Okay? All right. Let's go. Next one. Copy that one. Example 6. Yeah, so for tonight, not Fortnite, for tonight, in your home play, you're going to have some of these with a graph. That's why I'm going over these. Also like the ones that we did, the compound, and also what's coming up right after this. Here we go. So let's do this one together. If you were to tell someone what kind of compound inequality this is, it would be a what? Or. So check this out. So that you can be clear as to what it is, make sure you write it here in the space, in the empty space. It's an or. Okay, does that make sense? So like that you won't forget. All right, next. We need to write an inequality. Let's start one side at a time. Let's start with this side. We need a variable. Which variable do we use? X, and what's my dividing point? -3. Which number that's in the shaded region do you want to use to substitute for X? -4. Okay, I'm going to use -5. Bring down the -3. So out of those two numbers, we know that the number that's closest to 0 or always to the right is the greatest number, right? So if they were on the scale, which would be the heaviest or the greatest? -3, that means this side drops. That means that arrow is going to point that way. Over there? And then it's a solid point. Guys, focus. So now that I have the inequality for this side, I bring down the big old word of or, and now I want you to write an inequality for that side. See if you can do that by yourself. Hurry up, please. Okay, you started off with a variable, and the dividing point is what? 2. So which number do you want to use to check? Okay, let's use 3 and 2, which is greater, the 3. So that means if they were on the scale, this side drops. That means it goes that way. But it's a solid point, so it's like that. Are we there? Am I done? No. Solution set of X such that, that, or that. Okay? So I'm going to finish up here with the graphing part. 4, 5, 4, 5, 4, 5, 5, 5, 5. Okay. All right. And that takes us to this next one. Let's crank it up a notch. Copy that one. Example 7. This is probably the last one. Hurry up, please. Here we go. And let's do this one together. It's an absolute value. We already know how to do these. Line down the inequality symbol. Is the absolute value by itself? Yeah, so at this point we do two equations, but since we don't have equations, we have an inequality, but we still make this a -2. And this one is a +2. All right, writing utensils down really quick. Now, the last part, look up, please. For inequalities, pay attention, you're going to miss it. Pay attention, you're going to miss it. When we make the 2 into a -2, for inequality, what happens with the symbol? Flip it. It flips. We write x minus 1, and this one will be x minus 1 less than or equal to 2. And then you solve and you graph. Okay? Yes, this will be on YouTube. Now the graph for this one, just to let you know, this is going to be an and. Therefore, anything with the absolute value that goes to the right will be in OR. Your whole play is over here, the play sheet's over here. Exclude only problems 5, 6, and 15. You just do the rest. Have a good one, guys. Bye.